Okay, this is a much briefer version of a longer video, I think, right? The task we have is to be able to sketch a line segment, goes all the way across the piece of paper. We put point A here and B here. Now, we begin dividing our intervals in half. And I mean, we take the interval from A to B, we divide it in half, and we call that the midpoint. Okay, let's see how I do it. That's about okay. Now halfway between here and here ought to be here. Halfway between here and here ought to be here. Call this MA, call this MB. Then we go halfway between here and here. And then we go halfway between here and here. Now I did a little more on the other video. We're going halfway between here and here. We're going halfway between here and here. Okay, I didn't label these points, but I understand that this distance has to be the same as this distance, the same as this distance. It's the same as this distance, this distance, this distance, this distance, and this distance. All have to be the same within reasonable accuracy, within reasonable accuracy. And we don't want this interval to be this long, and this interval is this long. Gives us a distorted graph because we're going to use this process in graphing. Okay, so we can scale the interval then from A to B by putting a number for A and a number for B. If I put say 0 here and 16 here, then well, what's halfway between 0 and 16? You should know that instantly. Well, think it before you go on. If you don't remember, pause and think about it until you understand. 0 to 16, there's 8. Halfway between. What's halfway between 0 and 8? Well, that's 4. Which tells us that this interval has a length of 4. This interval has a length of 4. This interval has to have a length of 4. And 8 and 4 is 12. Or we just think, what's halfway between 8 and 16? 12. Be able to do that very quickly, very easily. Now, originally, in the original instructions, we divided each of these intervals into 8 parts. So, we have halfway here, halfway here, halfway here, so we're not going to bother with that right now. We're going to get down to the essence of what we really need to do. We can always subdivide these intervals together, smaller and smaller. Okay. So, we wanted to put 2 here, we could. Okay. What number goes here? Well, halfway between 4 and 8 is 6. What number goes here? Halfway between 6 and 8 is 7. Okay. Now, halfway between 8 and 12 is 10. Halfway between 10 and 8 is 9. And there we've got all our numbers plus 1 extra. There's 2 here. That was kind of sort of like we really need to do that. Okay. So now these numbers kind of run together. We don't have a number like 67,890. We have individual numbers. Okay. That's fine. We can do the interval from 0 to 1. What's halfway between 0 and 1? It's 1/2. What's halfway between 0 and 1/2? Think about it. Pause, think about it. Make sure you understand what number goes halfway between 0 and 1/2. So that number would be 1/4. Okay. Now, what's halfway between 1/2 and 1? Well, this interval is 1/4. This is 1/4. This is another 1/4. That's 3 1/4, which makes this 3/4. And we could number the rest of these. And we could actually then go ahead and subdivide. Let's say this first interval into 4 parts. Okay. So if we divide this interval into half, what's half of a 4th? Again, you should pause and think about that. Don't wait for me to tell you. Don't. Yeah. Think it yourself. You should know that that's 1/8. What's halfway between 0 and 1/8? Well, again, you should know that's 1/16. And so forth. We could number this whole interval from 0 to 1 in 16ths. And look at the previous video to see how that's going, or read the accompanying text. Okay. That's fine. That's good. we could use any numbers here and here. Some numbers are easier to cut in half than others. So if the interval from here to here has a total, well, the difference between A and B is a power of 2, we're going to be able to keep subdividing. And that's going to be handy. We're going to use that later. Bottom line right now is that A here and B here. Then we get our midpoint and midpoint that I call MA, midpoint MB. And then halfway there, halfway there, halfway from here to here, halfway from here to here. Okay. Now I've got everything subdivided. Took me, what, 20 seconds while I'm talking about it, to be able to do it that quickly. Now, practice until you can. Whoops, I want -2. I want the 46. Okay, -2 to 2. The midpoint from -2 to 2 is 0. Halfway from -2 to 0 is going to be here. That's going to be -1. Halfway between 0 and 1/2 is 1. Okay, halfway between 0 and 1 is, let's say halfway between 0 and 1/2 is 1. Halfway from 0 to 2 is 1. Halfway between 0 and 1 is 1/2. Halfway between -1 and 0 is -1/2. Again, notice that this interval is the same length as this interval. This is a distance to 1/2. Here's a distance to 1/2. Okay. This interval is half of this interval. This interval is half of this interval. We want that to be done with good accuracy. Otherwise, you're going to end up with distorted graphs when you do the toolkit functions, which we haven't even talked about. Okay, so there we have it. And these are our standard values. Toolkit function. We're going to illustrate those functions one at a time, a separate video. Got to illustrate pretty much basic. Okay. I'll use this word domain. We haven't defined it. We don't know what the domain is. We'll see. But the domain of standard domain. Domain is a set of numbers, -2, -1, -1/2, 0, 1/2, 1, 2. Where that's possible. Because for some functions, it's not possible to have these numbers in the domain. If you're doing 1/x, 1/0 is undefined, it can't be defined, it's not possible. And there's some other restrictions that we won't move on. Okay. Again, bottom line, be able to do this construction quickly in a minute or less, preferably in about 20 seconds or less. You don't even have to write out what I wrote here. I'm just telling you where this is going. Be able to do this, and then maybe list those numbers. And yeah, I sure hope the video wasn't as blurry as it looks. Might have been. You can you were able to see it okay. Unfortunately, our camera doesn't have the ability to use a fixed focus. It's very irritating, and I'm a little irritated by this. Because I'm trying to get this stuff ready for you, but that's all right. We'll live. Okay. Again, bottom line. Here we have it. This interval should be the same as this, should be the same as this, should be the same as this. This interval should be the same as this, should be the same as this, should be the same as this. And we'll also divide this last little interval in half. We want to label it. This would be -2, this would be 2. Make sure we're still focused. 0 here, halfway between -2 and 2, halfway between -2 and 0 is -1, halfway between 0 and 2 is 1, halfway between -1 and 0 is -1/2, halfway between 0 and 1 is 1/2, and then we don't label these 2 points, but we're going to want to understand where they are, because we're going to need them in the next video. Okay. And similarly, I've illustrated the fact over here that we put any two numbers for A and B, 0 and 16, and halfway between 0 and 16 is 1.8, halfway between 0 and 8 is 4. This interval has length 4. This interval has length 4. This interval has to have length 4, it's equal to the others. So you're going to get 8 and 4 is 12, and then you can label the other points. You can also divide the interval from 0 to 1. Okay. If we go ahead and divide this last interval from A to MA into 4 parts, then we have 4 parts here. We could have divided this one into 4 parts, this one and this one into 4 parts. We would have divided the interval from 0 to 16 into 16 equal parts. Just looking at this first interval, we would have 0 here, 1/4 here, because halfway between 0 and 1/2 is 1/4. Okay, let's back up. Halfway between 0 and 1 is 1/2. Halfway between 0 and 1/2 is 1/4. Okay. So this interval is 1/4. This interval is 1/4. So this interval is also 1/4, which means that this has to be 3/4. It's 1, 2, 3, 1/4. And of course, 1 is 4 1/4. 4/4. Halfway between 0 and 4 is an 1/8. Halfway between 0 and 8 is a 16th. And you should know that about fractions. Not everybody does. So I want to review that. I don't want to think about it. Okay, well, that's a quick summary of what you need to be able to do. And the main thing you need to be able to do is subdivide this interval. Then I said that these numbers you get when you do just this, give you the standard values in the toolkit functions. They're numbers that are easy to evaluate. They're numbers that are sufficient to show us the shapes of the functions when we graph them and so forth. So we're going to continue on and look at how we construct a few of the toolkit functions. Okay. Here's the picture. Camera needs to stay focused and it won't. Let's have something to look at. Okay, so y equals f of x equals x squared. That's a function. Now, you might not know what f of x means. Hopefully you do, but we won't assume that you know what that means. It should sort of become clear as we run through this exercise how we use the f of x notation. It's very handy notation. Okay, this is called the toolkit. Blurry function. It could also be called the toolkit quadratic function. We want to graph this function. So we make a table. We put x here. Put y equals x squared. Here, and actually, that's to be consistent with using the function notation. Write this as y equals f of x equals x squared. Again, don't worry about what that f of x means. We'll give you a little indication here shortly. Okay, and then we have calculation. Okay, so we have a column for X, we have a column for Y, and we have calculations. The numbers we use, and I think we'll take a picture down now. Numbers we use for X are the standard X values that we get by subdividing the interval from 0 to 2. Okay, so those are the values: -2, -1, -1/2, 0, 1/2, 1, and 2. Our standard X values. We evaluate Y at each of these values of X. Okay, well, if X is -2, we're going to do our calculations over here. In the line, in the row where X equals -2, we get Y equals F of -2 equals -2 squared. Okay, now all we've done is we've replaced X here in the definition of our function with -2. This X becomes a -2, this X becomes a -2. We put parentheses around the -2 because, side note, -2 squared is -4. Okay. Because of order of operations, the square only applies to the 2, not to the negative sign. This function says you square X. If X is -2, that means you square -2. What's -2 squared? Okay. Again, if you plug this in your calculator without parentheses, you might well have something wrong. It depends on how your calculator set up. It might tell you -4. Well, we're not going to use a calculator. A calculator bypasses the whole process of understanding what we're doing. We need to understand these functions. We need to understand the arithmetic. We don't bypass the arithmetic by using a calculator. Now, if you want to evaluate this function for 396.87, by all means, use a calculator. These numbers are all very simple. We can calculate the squares of these numbers very easily using rules of arithmetic as opposed to a calculator. Okay, so we do -2 squared. Now, what does it mean to square a number? It doesn't mean you punch it in your calculator, hit the square button. It means multiply that number by itself. And if you don't understand that, it's going to cause trouble. Okay, if you kind of lost track of what it means to square a number, and many people enter your pre-calculus class, certainly not everybody, but a lot of people don't really know what it means to square something well enough to apply it in pre-calculus. Now it's easy to fix that, and that's what one of the things we're doing here. Okay, so we got -2 times -2. Well, what's -2 times -2? Well, you got a negative times a negative. It's going to have to come out positive. And you got 2 times 2, which is 4. And of course, everybody knows that. Okay. So now in this, well, I put 4. All right. Well, what about -1? Well, calculations column. We write out the definition. We always write this out. We don't skip steps. Not at this point of the course. Later on, certainly, but not at this point of the course. Because if we skip steps, we're going to lose a third of the class. It's that simple. Okay. A third of the class, then having skipping steps, get a little further into the course, and they're lost. Okay, It's real easy to get lost in this course if you don't do everything very methodically and do it correctly. Okay, so we're going to methodically and correctly write these expressions out, even when it becomes tedious. Well, then that means -1 times -1. Negative times a negative is a positive. And we could even write out, that would be a good idea. We multiply two negatives, we get a positive. That's a rule that we have to use. We're gonna write out the rules. I recommend we write that rule. Okay, now here, -1/2, you got y equals half of -1/2. That's -1/2. That's -1/2. What's that? Well, it's gonna be positive because we have a negative times a negative. That's a positive. It's got a numerator that's 1 times 1, and a denominator that's 2 times 2. Why is that? Because the rule is when you multiply fractions, you multiply the numerators and you multiply the denominators. So there we have it. And then that gives us 1/4. And of course, another way of saying it is half of a half is a fourth. You take 1, you divide it in half, you got a half. You divide that in half, and you've got a fourth, because take 4 of these to make 1. In all those ways, you need to understand why -1/2 times -1/2 gives you 1/4. Okay, well, 0, that's actually comes up pretty easily. It's f of 0, which is, I left out a step up here. Anyhow, it comes out 0. I maybe better start filling my numbers in here. I left out here, and I'm gonna go back and because I do want this to all be complete. I want you to do it. Every bit is complete. We're gonna get y equals f of -1/2. By the definition, it's -1/2 squared, and I didn't write that. And that's -1/2 times -1/2. Positive numerator times numerator, denominator times denominator gives 1. Okay. Well, anyhow, down here, 0, we get 0. So let's fill in our results. We've got 1 here, so it's going to be 1. We won't bother writing the plus sign, but I do write it here to emphasize that we multiply two negatives. That's why we got a positive result. Okay, for -1/2, we've got 1/4. Okay, well, you should write out all the details and the rest of them. But the results, if you understand everything we did today, numbers are going to be pretty obvious. And we're going to get 1/4, 1, and 4. I'm gonna ask you to write these out in detail, and when you come into class here in my class, you're very likely to get a quiz that asks you to do this. And at some stage in the course, it's gonna be all or nothing. If I don't see everything, it's a zero. Okay? We have to master this. We have to understand this in all its detail. Everything that I've written here is important. It's going to be important throughout the course. And it's getting you used to the function notation, which I still haven't really defined. It gets you used to the form, gets you used to what it looks like. So when we explain it, it'll be easy for you. Okay. So there we have it. There is toolkit function, a table that gives us our X and Y values. Now, what do we do once we have the table? Well, we're going to construct a graph. So obliterating, we're just hiding everything else that we did. But what it comes down to, once we constructed the table, those are the points that we're going to want to, each row gives us a point that we're going to want to put on our graph. Now, how do we construct the graph? And well, we start, and you know this, we start with an x-axis. And our numbers go from -2 to 2. How do we write the scale for the axis? We divide this interval from -2 to 2.5. Tells us where 0 is. Divide this in half, tells us where 1 is. Divide this interval in half, tells us where 1/2 is. Here, you get -1. Get -1/2, and then we'll put the 1/4 in there, although we don't really need this graph. Okay. So right there's our x-axis. And it has all the numbers that we're going to need. So we don't need 1/4 because 1/4 is not one of our standard values. We could have chosen to make 1/4 one of the standard values, but it's unnecessary. We get the shape of the curve just fine. Now, the y-axis, well, that's a line where x equals 0. Now we notice that the numbers that we're going to have to plot for our y's go from 0 to 4. Okay. So we're going to have a interval that goes from 0 to 4. So we're going to put 4 up there. And then we're going to divide that interval in half. Okay, it comes out about here. So that should be 2. And then divide that in half, that should be 1. Divide this interval in half, that gives us half. Divide this interval in half, that gives us 4. And I didn't label the half and the 4 because the labels are going to kind of get in our way when we write our points. Okay. But we understand. I mean, certainly understand. That's 1. That looks like half of 1. There's half of the half. Now we plot points. Well, the point corresponding to x equals -2 has a y coordinate of 4. X equals -2 here, and x also equals -2 everywhere above and below this point. So this is our line. X equals -2. Just write it with dotted line. Make sure it's pretty vertical. Okay. And y is 4. So there's a line for y equals 4. Y equals 4 here, and y equals 4 everywhere horizontally across from this point. So that -2, 4 is where these two lines intersect. X is -2 and y is 4. There's our point. Okay, well, we can do the same for -1 and 1. Okay, we can draw our x equals -1 line. And our y equals 1 line. And where those two lines intersect, we've got a point. Now, you might not be used to drawing these lines. You might be used to graphing just when somebody gives you or puts on a screen a nice grid. Okay, you can be able to construct your own grid. It's more flexible. You have more flexibility. You can set it up the way you want it. And it also gives you a visceral, tangible picture of the graph that you actually constructed. Nobody had to give you that. And it's not difficult. Just have to practice it. Okay, well, then -1/2, 1/4. Well, x is -1/2. And y equals 1/4. At this point way down here. And then we got 0, 0. Well, here's the line where x equals 0. The y-axis is the x equals 0 line. And you really want to kind of slow that away because that is very important. Fairly early in the course. And the x equals 0, I'm sorry, the y equals 0 line is the x-axis. So here's x equals 0. X equals 0 here, everywhere above and below. Here's y equals 0. This point on the y-axis, which is the 0 point, and every point to the right and left. So we have this point. And then we have 1/2, 1/4. Well, all we got to do is draw x equals 1/2 line and see where that intersects y is 1/4 line. And then 1, 1, x equals 1, y equals 1. Here's the x equals 1 line. And the x equals 2 line. That line kind of goes a little to the right, so my graph is not going to be perfect. Certainly with yours right by hand. Okay, so now I've got these 7 points. Okay. Now you will then actually want to connect the points, but we're not going to do that just yet. Okay. What I call the basic toolkit squaring function consists of these 7 points, no more. There's no curve. There will be. We're going to extend this to a curve, but we're not going to do that just yet. I do this partly to illustrate the whole idea of domain and range. So let's just write this out. Basic toolkit squaring function is the set, and we use set braces here. We use a brace. We don't use parentheses. We don't use brackets. We use a brace. That's how we indicate a set. And I'm relatively sure everybody has seen that. People tend to get sloppy about this. We don't want to get sloppy. If we get sloppy, we're not going to learn what we need to learn. Okay, that's that simple. It's going to be very precise and make sure we do everything as precisely as possible. Not humanly possible to always do that. It's going to be slow things down sometimes. But okay, we use the brace. Well, that wasn't sloppy, it was just not sure what you call it. Okay, basic toolkit squaring function consists of the point -2, 4. And the point -1, 1. Point -1/2, 1/4. 0.00. The 0.1, oh, sorry, 1/2. 1/4. 1/1 and 4. 1, 2, 3, 4, 5, 6, 7 points. Or 7 ordered pairs. Corresponding to 1, 2, 3, 4, 5, 6, 7 points. That's it. Now, the domain of this function is the set of x values. Here's our domain. Here's our range. Okay, so the domain. And let's put this over here a little bit more. I'm less likely to block the screen if I'm going to this. This is our standard x values, standard values that we get when we start with 0, 1, -2 to 2, divide that in half, divide this in half, divide each of those in half. Okay. There we have it. That's the domain. The range is a set of y values. Now, what are the y values? Well, we can table see what the y values are. We got 4, 1, 1/4, 0, right? We've also got 1/4, but we already had it. So we've got 1 here, but we already have 1. We have 4 here, but we already have 4. So the range is just these 4 numbers. It's the set of the numbers 0, 1/4, 1/4. Why don't we list these numbers twice? If they occur twice, and we do, we do the domain, it seems like they ought to go twice, but that isn't, well, that's inconsistent with what a set is. The set just lists the numbers in the set. And then question is this number in the set? Yep. Is this number in the set? Yep. Is this number in the set? Yep. It's in the set twice. That's okay. But a set tells you, well, the definition of a set tells you, it gives you a decision process. You have a way of deciding whether a given number is in the set or not. Is 1/2 in the range? Yeah, we'll see 1/2 here. So 1/2 is not in the range. Okay. These are the numbers in the range. We don't list any of them twice because it's unnecessary. If all we want to do with this notation is figure out whether numbers in the set or not. Okay. So. Okay. So that's our basic toolkit squared function. Now we want to follow our impulse and connect these points. Now, one thing that I sometimes see, as often recently as before, people want to do a straight line from here to here, straight line from here to here, straight line from here to here. So you get this kind of a jaggedy graph, okay, with a bunch of straight lines that don't really represent the x-squared function. They represent the x-squared function. You're going to want to draw a smooth curve. Okay, so we draw a smooth curve. Let's see how smooth I can do that. Okay, it's better than I usually do, but it's not perfect. And when you do it, you're not gonna be perfect either. But there it is. Okay, now this curve's called a parabola. Okay, I don't want to write out squaring function, it takes too much room, abbreviated squaring function. Okay. Let's say it's a smooth curve through our 7 points, starting at -2, 4. And ending at the point 2, 4. Now, I'll comment on this a little bit. We need to get another board, so. Give me a second here. Okay, now this curve graph then should represent the square. Now, every point should represent an X number and a Y number, and the Y number should equal the square of the X number. So that we could actually use this curve to estimate some squares. For example, let's say we wanted to square -1.5. I'm going to use a different color here. Halfway between -2 and -1 is -1.5. So I sketched the line X equals -1.5, and I find that this point on the graph corresponds to X equals -1.5. Then I come across here, and I find the number, it should be the square of -1.5. So this number should be -1.5 squared. Here, but where is that on the y-axis? Well, we divide the interval from 0 to from 2 to 4 in half, and we get 3. We can divide that interval in half, and we get 2.5. We divide that in half, we get 2.25. Well, if I estimate this, I get something probably around 2.2. Okay, it's a little less than 2.25. So I'm going to say maybe it's about 2.2. I'll say that's approximately equal to 2.2 according to my graph. Well, my graph isn't perfect. Matter of fact, I know, and you can figure out very easily, that 1.5 is 3 halves, and if you square 3 halves, you get 9/4, which is 2 1/4. It's 2.25. It should be right on 2 1/4 there. It's a little bit low because my graph isn't perfect. And as a matter of fact, I was going to do 1.5, but I come up here and, well, you notice I was a little bit to the right of this point, and a little bit to the right of this point when I sketched the curve. And it's a nice smooth parabola sort of, but I missed my last 2 points. So I wasn't going to get a good answer. Okay. Point is, if I give you an X value, you can go to this graph and get a reasonable approximation of the square of that X value. I'll give you any number between -2 and 2. You've got a good graph. You should be able to estimate within 1/10 or so what the square of that number is. Okay. So the extended toolkit scoring function. And I actually over here called it the extended basic scoring function. As a matter of fact, and the extended basis scoring function. Extended toolkit. Scoring function. Smooth curve through the points of the basic. Toolkit scoring function. I'll go with that. Yeah, what it- That's why, oh, that's why it's on the curve. If, and only if. Y equals n squared. And we can use this to make estimates. The definition. Y equals f of x equals x squared. Now we say it starts at -2, 4 and ends at 2, 4. So my x values start at -2 and end at 2. Now we could do the complete toolkit squaring function, but we have a hard time drawing it because it goes on to infinity in both directions. But we understand that we can extend the extended function to the complete function. The extended toolkit scoring function, extended toolkit scoring function. What I define it. Is defined for x values from -2 to 2. -2 is less or equal to x, and x is less or equal to 2. Its domain is the x interval. -2 to 2. Its range is the y interval. From 0 to 4. Because what? The x values have to be between -2 and 2, and we don't exclude any of them. The y values can be as low as 0 or as high as 4, and we can take every y value between 0 and 4. So that's what we want to know about the basic toolkit scoring function.